Hi. So here we are looking at one of the most important process in chemical engineering, the ammonia production. Ammonia production was responsible for the major green revolution in the world to feed increasing population. So it is one of the most important process in chemical engineering. The sources are standard books and ammonia plant from RCF, Chembu library. So ammonia, as you say, is NH3. Now when you speak of ammonia, what do you expect? There is a nitrogen and hydrogen. So let's think over what would be sources of nitrogen and hydrogen for a given process. Just 15 seconds so you can think over this. Okay, so what is the answer? Look at this. So very obvious, nitrogen source is air, which is very cheaply available. Whereas what about the hydrogen? Hydrogen is a very crucial part. So let's look at how do you produce or get hydrogen from different sources. So people have developed various routes to produce hydrogen. The first, it was simply produced by a reaction of iron with sulfuric acid to give you ferrous sulfate and hydrogen. This was the initial crude process because the need of hydrogen, nothing was available. You just take iron, just put it into concentrated sulfuric acid and you start getting hydrogen. But this yield of process is very low. Then after a next century, 100 years almost, people have found out a reaction of electrolysis which generate electricity. Okay, so let's look at different major processes available to produce hydrogen. As you know, coal is abundantly available, so you can work on coal gasification, which gives you hydrogen, and the carbon monoxide which comes with it. A second process people have discovered is a methane reformation, a steam methane reformation. Now if you can see at reaction 1 and 2, which would be a more efficient process to get hydrogen? Coal base or methane base? So how do you decide? You can see a right hand side. Here you are getting 1 mole of hydrogen, whereas in the second process of steam methane reforming you are getting 3 moles of hydrogen. So obviously this is 3 times more efficient compared to our first process. So that's why this has become one of the majorly used process to get hydrogen till date. Look at the energy requirement of different processes. You can see the process of water electrolysis. Very simple, very clean process, but energy requirement is very high. Coal gasification is come on second number energy requirement. There is a heavy fuel oil gasification, a naphtha reforming, and then a gas reforming. So you can see a methane reforming is a least expensive in terms of energy. At the same time, it gives you a maximum moles of hydrogen in product. So that's why this is the one which is preferred over all other processes. Let's look at the history of ammonia manufacture. So the first attempt was done in 1784, but the patent was taken by a Haber who developed ammonia in the lab. Haber got a Nobel Prize for making hydrogen at high pressure from nitrogen and hydrogen. Whereas the first commercialization or a scale up was done by the Mr. Bosch at BASF, which he also got a Nobel Prize for his work. And this process combined is called as Haber-Bosch process. The first commercial plant plant with 30 metric ton per day of capacity is established in 1914, whereas a world capacity, you can see it started in 1914. Only in 14 years it reached to 2000 metric tons per day, because it has the potential to act as a very important component in fertilizer. So you can increase productivity in the field, and it helped to feed an increasing population of the world. And you can see its capacity reaches 450,000 metric tons per day in 2005. So these are different processes how ammonia has developed. The Hayward developed in 1904. The first industrial was started in 1921. It was used during World War II. Let's look at the ammonia plant capacity by region. You can see in Asia, China produces 27%, India produces 8%, Indonesia 4%, all other remaining 7%. So now compared to a consumption of India, India produces a small amount, so obviously there are import required of ammonia. You can see a majority of ammonia goes into a fertilizer as a basic application, and a remaining will go into explosives as it was used in World War II, fibers, resins, animal feed. This is the chemical structure of ammonia: 3 moles of hydrogen, 1 atom of nitrogen. Look at the properties of ammonia. These are the melting point, boiling point, density, vapor pressure. So different physical properties. So it become lethal above 1000 ppm. If 1000 ppm it can suffocate person to death. Irritation occur at very low ppm, 140 ppm. These are some properties of ammonia. It is colorless gas. This boiling point, as you see, is a -33 at 1 atmosphere, so you can always find ammonia in a gaseous form. Of basic or very good quality of ammonia is it is readily dissolvable or absorbable in water. So if some leaks occur, water would be a best readily available substance which can arrest ammonia. Fire hazards, it catch fire in 16 to 25%. You can see the uses, majority in agriculture industries, fertilizer. It also has application in metal treating. Refrigeration is one of the biggest area beside agriculture. Then wastewater treatment, rubber industry, food industry, pulp industry, leather industry, household cleaning, and pharmaceutical industry. Let's look at what are the Indian manufacturers of ammonia. So Brahmaputra Valley Fertilizer as a major application in fertilizer. Then the RCF in Mumbai, National Fertilizer Limited in Vijaypur, Fertilizer and Chemicals Limited in Kochi. These are the private players into this. You can see a growth of ammonia production. As the population increases, there is also requirement to increase rate of production. Also, as we required, India produces 8%, so there has to be imports. So you can see imports also are increasing, because as population increases, the demand for ammonia fertilizer increases. So this covers the brief about introduction to ammonia. In next presentation, we will see the actual process followed by safety. Thank you so much.